Our topic is Euler's method. The Euler's method is used for solving ordinary differential equations. So before understanding the algorithm of Euler's method, we understand the concept of Euler's method. So the concept is, suppose we are given any differential equation here, dy by dx is something an equation, you will be given the boundary conditions side, like suppose you are given is equals to 0, the y value will be 1 and you have to find y value at x is equal to 0.1. So what will we do? We first find out h is the difference, so h is will be found out by b minus a by n, where n is step size which will be determined in the question, or you can take by yourselves. Then b minus a means 0.1 minus 0 divided by step size. Then you have interval slide. Suppose initial interval is x is equal to 0, then the second interval will be the x0 value plus h, then second interval will be x2 values plus h. Here will come x1 plus x0 plus h, x1 plus x, x2 plus x, our new interval, and you will find the value of y by putting the value of x in this formula, which is yn plus 1 is equals to yn plus h bracket xn plus yn. You find the values of corresponding y with corresponding x. So this is all about the concept of Euler's method. So now we are understanding its algorithm. First start, then define the function f x comma y, which is our differential function. Then we have to read our initial conditions x0 and y0, and we have to define number of steps and insert the point for which we have to find the value, that is xn. Then we have to calculate step size by formula h is equals to xn minus x0 by b. Then we have to set in step 5 set I is equals to 0. Then in step 6 we have a loop which will be going to find yn for corresponding xn with the help of this formula. Then we will going to insert y0 as yn and increase the loop by 1. These keep working until I comes greater than n. Then we display the last calculated value yn as the result and stop our program. So this is the algorithm for Euler's method. Now we are going to discuss the C program for Euler's method. First we declare standard libraries. Then we define a function float fun, which will take arguments as float values x and y. In float function we defined a float variable f, in which we have to write our differential equation, that is f is equals to x plus y, and the calculated value of x plus y will be stored in f and f will be returned as the value of the function. Then the next comes the main function. In main function we declare x0 y0 as our initial conditions and xn, for which we have to calculate the value of yn. Then we declare a slope variable which will store the value of fun function. First we enter our initial condition x0 and y0. Then we enter the point for which we have to calculate yn, so we entered xn. Then we define the number of steps, this is our step size. Then we calculate h by xn minus x0 by n. Then here we have a for loop which is I equals to 0 to I less than n, in which the function initial values x0 and y0 are passed as arguments in fun functions, and the value returned from fun function is stored in slope variable. Then yn is calculated by y0 plus h into slope. This yn is the resultant value for corresponding xn. Then we store y0 as yn and increase x0 plus by h. Then when I is comes greater than n, this will come out of the loop, and the last calculated value of xn is our result. So this is the program for Euler's method. Now we have a question for Euler's method. Suppose you have given a function differential function, that is dy by dx is equal to x plus y, and you are given boundary conditions y of 0 is equals to 1. So y of 0 equals to 1 means that y0 is equals to 1 and x0 is equals to 0. This is our x0. Then we calculate the total number of steps by h equals to xn by n, that is 1 by 10 is equals to 0.1. So our h will be 0.1. So in iteration 1, our initial x is 0.0, y is 1. We calculate dy by dx as x plus y, and this is our calculating for our new y. So this iteration keeps working until which value we have to find. We have to find 1.0. So at 11th iteration, the value of 1.0, that is x, is 3.8187, that is our y. This is our x and this is our y. So this is the example for Euler's method.